Hello and welcome to another tutorial. So this time we're going to be extending the character motor, but we're going to be extending it to make it so that not only can it support input from a player, but it can actually also support input coming from an AI. So there's going to be a couple little tricks we'll see in terms of refactoring code. So that's going to be a bunch of the focus of this, of looking at how do we refactor something when we've got a fairly established system there, and how do we manage to make that work? So that's what we're going to dive in and take a look at. Okay, so I've brought over the AI stuff, so we do already have the AI currently working. So this is a NavMesh agent based one. So this is also going to involve us making some changes so that we can actually override what the NavMesh is doing. But the first side of this I want to work on is actually the character motor side of things. So I want to go and update it. So I'm going to go to that scene where we've got the player character motor. So this is going to be the first one, focus on updating. So if we take a look at the setup that we've currently got for this, so with our character motor, we have a bunch of things here. We've gone into and made sure that a lot of things were already protected, which is good. Don't believe there's anything that is maybe private. So the awake is, so that's one that I'm going to switch anything that was private over to protected. So I just want to do that at the very beginning. And then I want to check, so no other ones that are private, except for a couple of ones where we haven't indicated, so it will default to that. So things like the update, I want to make sure those are protected. And doesn't look like there's anything else. We look to be in a pretty good spot. So how I want to structure this is I want to have character motor will be the base class, and then I will have player character motor that will have the player specific stuff. So working with things like the input system. So what I'm going to do here is I'm going to create a new class that will be player character motor. So we're going to create a C# script, player character motor. And initially, all I'm going to do is I'm going to mark this as inheriting from character motor. That's the main thing I'm going to do initially, is say that it inherits from character motor, and that should mean a lot of the stuff just works. So now that I've set up that player character motor, it's inheriting from character motor, so it's got all of those parts there. What I need to do is I need to switch this over so it's using that script. So what I could do is I can actually select the prefab. So I can go to the actual prefab, and if I turn on debug here, then I can update this so that rather than linking to character motor, it links to player character motor. And so then when I select our player here, you can see it's properly showing player character motor. And we just want to test, make sure when we run it, we should expect that we can still move around. So we can move, things like that are behaving as expected. We can jump, all of those are behaving correctly. Now, if we just run it again, now we can see that we're not getting updates coming through with the stamina. So that's something where we do want to check and see if we go to our things like our stamina and check on that. We want to make sure that everything is feeding through correctly. So we can run, we can see, okay, yep, max stamina's that, current stamina is like that. So that's come through fine. You can see max bar length is 0. So this is something that in terms of initialization order. So this is something to be aware of and that we actually need to fix with the character motor. So the sizing of things, we may not actually have it at the point start runs here. So we want to go and check, well, if that width is greater than 0, then we could reasonably update that. And the same is going to apply for our health bar. So our health bar should actually do the same check. So if health bar transform .rect .width is greater than 0, then we can update this. The other thing we would then need to do down here is we might not have that length set. So we can check, well, if max bar length is 0, we'll update it. So we just have a couple of little bits in like this, just to make sure that regardless of sort of initialization order, the timing of things, that everything works correctly. So we'll bring in our stamina bar transform. So this should mean that everything's working. So this is something where we didn't change anything significantly, we just changed what stuff was inheriting from, but we did end up that exposed an issue with the timing of things. So we can see everything's working there. Those settings are back as they should be. Now we could look and see, okay, are there things from the character motor that makes sense to move into the player character motor? And there absolutely would be some ones where that would potentially make sense. So things like head bobbing, well, head bobbing is something that applies to player characters. It doesn't really apply to AI characters. So there's things there like that we absolutely could move over. A lot of the stuff that's working with the input system. So all of these bits for working with the input system, those actually make sense just being in the player. So there's a bunch of ones here where what I would do is I would take all of these and I am going to initially cut, even though we know that that will cause an issue, like that will cause errors, that's fine. I want to cut and bring those over here. And similar with this, like this is then going to have a whole bunch of things like our input system. Well, that doesn't belong in character motor, that belongs in this one. So then things like our inputs here, these actual protected values, those do go into the base, because that's the things that we want our AI to be driving. So the character's looking around, absolutely, running, crouch, all of those inputs, those can be things that the AI can choose to send through. Now, you can have the AI just be going very low level and directly controlling things. There can be some advantages to having it send through input stuff, though. One of the big things being is that it means there's a much closer overlap between what a AI is capable of and what a player is capable of, and that can be really beneficial. So we also need to bring in event systems because we have our pointer data here. So these parameters all go back over into the character motor because these are common ones that all of the characters require. So I'm going to bring these down to here. Stuff like these UI interactions. So there are things like the awaken that. Well, those absolutely make sense going into the specific one because UI interactions, AI, does it need to be doing it? Not really. So send UI interactions. I'm going to bring that over. So we progressively just bring over the ones that we know we're going to, that don't sort of make sense for particular ones. This means the awake, well, that needs to be a protected virtual void awake. And then in our player character, we end up with a protected override of the awake. We run the base version. and we update the send UI interactions. So that looks good. Now this is updating a particular camera. Now that's something that also we would likely switch over. We just want to check for any other things with those UI interactions, and it doesn't look like it. So the camera, well, that's one as well. That will move over. Now again, we could have this potentially still stay on the AI if we wanted to have the AI be doing some particular things with that. I'm going to move head bob over. So it's a little bit of a process splitting the stuff, but we rely on having the compiler, so when it's compiling the code, it finding stuff that we need to fix. So again, start is another one. Protected virtual. So we again, down here, I can hide the input side. Protected override for start. We run the base. We update the camera side. Again, these other ones looking good. Stuff like coyote time, things like if that still apply. The updating of the camera, well, that's one that entire function is going to end up going over. So our character motor ends up with another protected override for late update. Now this time, because of matching how we ordered things, we update the camera first before the crouch, was I believe. Yep. So I'm just preserving that order. So that means the update camera function, which is likely what this sea of red here is going to move over as well. So update camera will be brought over to here. So that's doing the head bobbing and everything as well. Now we can see that there is still one last little bit, and that's this for with the camera where we're updating it when we are in a crouch transition. And so it's getting the progress, it's updating that. And what we can check is if the character motor here, because we were doing camera and then late update, if I swap this around, crouch state I know will then be updated. So what I could do is make sure that that position one here happens inside this. Now I want to check and see if I'm already doing anything where I'm updating positions, and I do have a bit for with the head bob, but then I can just make sure I'm updating the position there. So that should split everything over. Cursor lock, those are ones that, again, those make most sense for being actually in, that one should actually belong in the player character motor. Because it doesn't make sense for the actual AI being able to control that, but it does make sense for everything else. So that means the set cursor lock true that was there. I can bring this over and put this in our start one. Again, matching what we did before, where the order, we preserve that same order. So the rest of that looks fine. Stamina, things like if that are good to be updating. Is it grounded? Sound effects, all of those are good to actually keep there. This means our AIs inherently then have stamina and health, which could be really quite useful. So there's a lot of bits there that we've got. So that looks pretty good. They're affected by the surface effects. Now what we want to do is we just want to confirm that we haven't gone and broken the character controller. So we've moved a lot of things over. So I can still move around. I can take damage. If I sprint, that changes. So that's looking good. If I crouch, So I can crouch, that works properly. So everything seems to be working pretty much right. Can check that these things like the speed up and everything work, which they seem to. Everything seems to be working pretty much right. I'm not entirely convinced head bobbing is working. So I'm just going to go and quickly check that head bobbing is actually happening, just to be certain. It should be happening, but we want to make sure that stuff like the head bob progress does actually get updated. Just because that's an important thing that we could easily have broken that. So we can see we get the speed factors. Head bob progress is changing, so that's good. It is working, and it is just small amounts of change, so that's good. So okay, we've got that properly split. Prefab, there's been a couple of updates to that, so we can apply, but that looks good. So we've got a version now that has the player-specific stuff in it. So then this is where we're going to switch over to the AI motor test scene. And much like the player, so the player one, this has a capsule in it, where it's got height, things like that configured. The AI motor is going to be a similar thing. So it's already got a rigid body assigned onto it. So I'm going to remove that. So it's already got a rigid body. It's got a NavMesh agent. So that's going to be something where we're going to need to override some of the NavMesh agent behavior. So this is going to get we'll add in now, we've got, and I'll put this in the AI side. We're going to give this an AI character motor. And the AI character motor is going to be based off of that character motor that we have in there. And what we'll end up doing is the navigation side here will talk to it. So the AI character motor is going to inherit from character motor. So we're going to do like of that. And it's going to set things up, so that immediately brings in all of those, which is great. Now, data-wise, we have our config here that is for the player character motor. Player motor config. I'm going to duplicate that, and I'm going to call this AI motor config. And I will actually move that script over in with the character motor. I think it makes most sense for it to be there. So we've got AI character motor, player character motor. And we've got our data there for it. So this, we will link it up to the AI motor config. Now, settings-wise, the heights here are a little different. So I'm going to just increase the height for the AI motor up to 2. Rest of the settings I will leave exactly the same. So it'll have all of the rest of the settings unchanged. And then, so our AI needs to be able to feed into it. So we need to take a look at our NavMesh here, because there's going to be some changes we have to make to this. Because at the moment, we don't actually do much to cause the AI to move. The navigation agent handles that movement for us. So we're actually going to be changing that. We're going to switch off the NavMesh agent. And then when it gets a path, we're going to feed the information from that path to the AI character motor. So this is now going to also require a component, a type of AI character motor, just so it has to be on there. Okay, so the first thing we need to do is we need to turn off the NavMesh agent controlling movement. So what we do in that case is I'm going to say linked agent, and we say update position is false. And we also turn off update rotation. So it's not going to be controlling the position or the rotation of the character anymore. Now that means we have to manually be controlling it, which is okay. But then we also need to handle, well, when we've gotten the path, how do we actually progress through that path? How do we actually, maneuver along the sequence of points? So when we get to this point where we've found a path, we run this on path found, and that's runs in the base navigation side of things, and we can take a look and see what that does. You can see that just sets the state to following path. So what I would do first is we can ask the agent for the path. So the way that looks is we can get path, and the path, the main thing we're after for it is the corners. So we can access the set of corners. So what I would do here is I would have vector 3 current path, and then I would have an integer target point. I'm going to set to -1. So linked path corners, so we'd go current path is equal to that, and target point is equal to 0. So that's checking, the ticking of the path finding. And the ticking of the path following, well, this changes a little bit. So this is the old approach of what we did. Now we actually need to be looking at, okay, well, what's the point that we're heading towards? So we need to get the vector to our target. So first, we get our target position. So our target position is our current path at target point. Now, generally when we're working with this stuff for working out sort of where we head to things, we kind of want this actually in 2D. A lot of the stuff we work with it in 2D. So what I would actually do is generally go target position dot y is equal to 0. And then from that, we can start to get things like our vector to the target. Actually, that I'll do when I get the vector to the target. So we'll go vector to target. So we go target position minus our current position. And then what I would do is get rid of the y component of that. So get the 2D vector to the target. Now, this is something where we can check if we have reached that node. So we would have a variable here, and we might have something in our base navigation, so we do want to just check if we've already defined it there. So we do have our destination reached threshold. So what we would check is f vector to target magnitude is less than or equal to. So have we reached the target point? Then what we would do is we would increase what our target one is. So we'd go plus target point. And then we would check, well, if target point is equal to current path.length, then we have reached the destination. So we've reached the destination, and I would actually do a return at that point. So reach destination, advance to next point. And we could put in stuff here for shortcutting as well, so it could look a few points ahead. That's something that's absolutely an option of what we could be doing. So otherwise, well, we would actually change here, and again, I'm going to refresh target position, and I'm going to refresh all of this. So refresh the target information, because if show heading is enabled, then we can be doing that. So it means we still have that debug happening. So that's good. We'll have the debug logic there for indicating that, which is great. Find nearest point, those ones can all stay exactly as they are. Stop movement. What we would do in the case of something where we need to stop movement, we do want to reset the path on the NavMesh agent. But that is also something where there's a couple of extra sort of things we would do there potentially. So I would do something like current path is equal to null, target point is -1. So that looks good. So far so good. We've worked out our vector there. And then this is something we could be providing as input to the character motor. So this, we could largely treat this as, if we take a look at what the character motor has for input values, we have, just a bit down here, our move input. So our move input, we should be able to set it based upon that. So we should be able to say something like, we'll feed that directly through. But for now, we just want to check and see that this is actually drawing the lines so that we know that it's working out the right path. Okay, so let's see at the moment. So it shouldn't manage to move anywhere. We also shouldn't get any crashes, but we should hopefully have. So we do get a issue, so that's good. We do want to check with that. So that's something where it was having an issue with the stamina. So that's because it's looking for a capsule collider and we don't have a capsule collider. So that's an important thing. So we didn't link this up to the AI motor config, so we've got that set up now. Oh, we actually ended up with 2 copies of that. Let's fix that. I think that might have been with some of the prefab shenanigans. So there we go. That's good. So we need, it does potentially need a capsule linked up to it. So what we will do is, it already has a little bit of stuff there because the NavMesh agent adds that in, and I think the body has a capsule collider on it. It does. So I just want to check the setup on the player so we can make sure we match its setup, because it has a capsule collider that's not a trigger. Its center is a bit above the ground. Now the one for the body here is not organized like that. So this is something where we're probably going to run into a bit of an interesting issue with the relative positioning of things. Because if we look at the player is positioned such that the capsule is offset like that. And so that's something we might find we need to do a couple of changes there because they're working a little bit differently. So that's something that we may run into with this. So what I will do is, it looks for a capsule collider and we can see how it tries to find it. So what I would do in a case like this, I'm actually going to make it that this is a serialized field and it only looks it up if it's not provided. So if it's not provided, or we could actually do get component in children would also work. So I think that's another option as well. So if we do get component in children, which should retrieve it whether it's on the parent or on the child, which we will just verify that. We'll just do a quick test of the player one. This is something where anywhere where we make a change to the low level, we do want to just double back and check that we haven't gone and broken something for the player. It'll be very, very easy to do in a scenario like this. So I'll test that. It should now have that, which is good. Now we see it is sinking into the ground. That's because it's got that offset. So that's something where we want to take a look and see what it's actually shifting. So the simple AI is there, and we want to check if it's changing its actual position or if it's changing the body. And it looks like what it's changing, we can just watch the capsule collider again. Capsule collider gets set to 1. So we want to take a look and see where we might be making, and we do make some changes to the height. So we can actually see height, center, things like that do get adjusted there. So that means we need to make some changes to this AI. And this potentially is going to make things a little bit interesting, but we can offset the NavMesh agent, so we should be okay. So its height is 2. So we want to set its offset to 1. This goes to 0 for its position. But that we can see offsets the visual mesh. So what I might do is I might actually remove the capsule collider from this. So it loses its capsule collider. We add capsule collider onto the parent here. After, what I'm going to do is just create, just as an easy way to tell where it's positioned. So that's good. So simple AI is actually positioned at the right spot. That capsule for it, we can see, and it gets a little bit messy when we've got multiple things like this, but we can see, and I'll turn off just for now the NavMesh agent because everything draws a capsule. So this one, we want its height to be 2, 0.35 and 1. So it looks pretty good. We can turn the NavMesh agent back on. And then we can test, we'll apply those changes, can test with that, and we're hoping that to see that it essentially stays at about the right height, which it does, which is good. And we can get rid of that. We can take a look at the scene. So that looks okay. So we want to check that it's getting here and calculating where to move. So we want to make sure the path status, things like if that complete. So we can run, and it does complete. We get a path that has a couple of points in it, which is good. And the first point there in it is nearly 0. So good to just check transform position. I just want to make sure that we were near 0. That's good. Because one possible thing that could have been the case there is that it was giving us points that were relative to our location, which would not have been good. So that looks okay. So tick path following is running, gets a vector to the target, advances the point. That looks good, gets a new one. And so it's calculated the vectors, so that looks pretty good. It's calculating the information that we need there, so that is excellent. I can now get the AI character motor. So AI motor. And I'll retrieve that here. So AI motor. Because what I want to then be able to do is come down here and go, hey, AI motor, set heading. And I want to be able to give it vector to target. So X and vector to target dot Z, which X corresponds to the horizontal and Z corresponds to the forward. So, okay, that'll give us what we need for the AI character motor. So then it gets its actual first function. Public void, set heading. And so we'll set, so float, we'll call this X and we'll call this Z. Because then if we take a look at the input the character motor has, this is going to correspond to our move input. So input move, And that is going to be equal to, well, actually we can just do input move x is equal to x, and input move z is equal to z. Now, important thing with this is, well, set heading, that doesn't actually give us exactly what we need, because that's the direction we're trying to head in, but we need to look at relative to where we are facing. So there's actually more than just this. Now this will, in theory, get us sort of moving in a direction. I would generally need to normalize this. So this is not going to work exactly yet. We will need to make further changes, but this should make it move. And that's the thing that we want to just get a sense of is, does this actually move? I'm going to move this down here. And then we'll work and see, okay, so it does move. And it was heading to the microwave, so it did head to the correct location, which is good. But we need to sort of update how this is actually working a bit, because that just zooms it there as fast as it possibly could, which isn't really what we want. So we need to turn, and we also need to move. So there's a combination of what we're needing to be doing there. And this is something where there's different ways of how we can approach this. So what I would generally do is I would look at, okay, we can work out where we're currently rotated, and we can work out a new rotation, which that's something we do need to feed through. So rather than doing this, I'm going to get rid of having a set heading, and I'm going to have it that I want to be able to calculate the turn input first. So I need to look at where I'm heading, and I need to look at sort of where I'm currently facing and work out a turn direction to meet that, which is okay. So what I can do is I can do a quaternion, and I can get a target rotation is going to be a quaternion. I can say I want a look rotation. I can just give it the vector to the target and vector 3 dot up. So that gives me the target rotation. I can get my current rotation. So current rotation is a transform rotation. So to get the angle between these two, I can do quaternion angle, give it my current, give it my target rotation, and this gives me the delta in degrees. So angle delta, like that. So we've normalized the vector to the target, we've worked out the rotation, and that I'm going to get rid of that normalizing for now. So we've worked out the angle delta. So what I can do is I already have a turn rate. So character motor, I do already have the concept of sort of turn rates and turn inputs and things like of that. So I need to be able to convert this angle delta into that sort of turn rate. So this is going to be an AI specific thing, but I would have something like serialized field float turn rate scale. So this is something where it controls what that angle delta translates to in that -1 to 1 value range. So this would be something where, you know, how I set this up might actually even be better on the AI character motor itself for being able to translate it. You could kind of put it in either one. I think it fits better on the actual navigation side, so that the character motor stays just knowing that -1 to 1 range. So I'm going to say, okay, if we need to rotate 60 degrees, maybe that turn rate scale, it should do that in like 1/4 of a second. So I think we go for something around sort of 180 to 240 degrees. So I think that. So what I would do is then down here, I want to do AI motor, set turn rate, angle delta, divided by turn rate scale. So let's feed this in. So this will be public void, set turn rate, and if we take a look at the character motor, that's going to be our look input and the look input.x. So x, we clamp a rate between -1 and 1. So we just want to see if this is going to rotate in the correct direction. We might need to flip signs, we might need to change rates of things. We'll get a sense when we run this. So in C, it didn't actually try and do any rotation. So we just want to take a look and see what's happening there with that. So if we place a breakpoint, you can see it's got an angle delta. It has absolutely worked out a turn rate and it's set that. But here's the thing. If we remember what we had here, the update camera actually does a little bit more than just updating the camera. So this is something where that updating of the camera, we're actually going to move this so that there is some of the level of this that happens inside the actual common code, because this local rotation here, that is the part that is not happening, that we need to actually have happen. So what I might do is grab this, and the AI character motor is going to have all of this, but we're going to then get rid of, so we can lock looking around. Having it ignore for a time is not going to be a thing that this needs. It doesn't need vertical sensitivity. So we can get rid of that. Doesn't have pitch. Controls the local rotation. And it doesn't have head bobbing. And we've already updated those other bits. So it just does that. So that should be good. So now it'll rotate. So there'll be things like this that at times we'll find. So I want to see. So it is rotating pretty slowly. So that scale factor, we can adjust that. So that's something where I could adjust that and say, okay, well, that rotation turn rate scale there, what we were doing, let's see if we drop that to say 60, what happens then? It's still rotating around pretty slowly. So we do get pretty slow rotations happening there. We can check and see what's being fed through. So the rate, it's trying to calculate a pretty large value, but it is actually still turning pretty slowly. And part of that is because it's actually hitting the limits of how fast we're allowing things to rotate based upon sensitivity. So this is something where we actually might want to unclamp that for something like an AI and allow the AI to just directly rotate. Because AIs, we generally expect them to rotate pretty quickly. We could still have clamping on this, and we do have, you know, that scale setting. Because we can see with that, that's a little bit better. But you know, we do have, does rotate that X value. So that's pretty low in terms of sort of the values that it's rotating there. We can further mess with stuff like the scale. So we could drop that down to say 10. So it should be much faster again, because we'll generally find we probably want it to be pretty quick. So that's a lot better. We do see it keeps rotating around. So it worked out rotation to be pointing towards, but then it actually kept going. So let's select the AI and let's run again, and we just want to watch its rotation there. So it does rotate around, it's supposed to be heading towards the TV. Now it didn't take the shortest path. So that's something where we want to check and see if it's consistently doing this. And so it does pretty consistently rotate the longer way. Let's just check. Yeah, it's pretty consistent. So likely what we might find is that we actually need a negative on that scale. We'll just take a look and see, does it need a negative on that? That rotated the shortest way. Does it consistently then always rotate the shortest way? It's going for the same thing. We can check again. So that was a slightly different one, but still rotated the correct way. So pretty consistently, at least for those, is rotating correctly. What I'll do is, seeing as it likes to keep going to the bookshelves, I'm going to turn off the bookshelves, just make sure for everything else it still rotates the way that we would expect it to. So that seems about right. Could have gone, I'd say, either way for the microwave. TV makes sense. That looks okay. There might be other things that we need to adjust there. We could check the specific values that it's trying to rotate. Would be things we could absolutely check there. So at the moment, we're changing the angle there. We're dividing it by this turn rate scale. We do have a rotation speed that we could be using. So we could do a mapping there where angle delta is sort of feeding into that. It's a little bit, it's not a great sort of conversion there that really sort of works, because they are quite different in terms of the sort of calculations that are happening there and everything. What I would be inclined to do is have something probably where we're feeding this through an animation curve. So I'd do something like a serialize field, and we'd have an animation curve, angle delta to turn rate, or to turn input. And so we feed our angle delta into that, is what I think is actually going to be a better sort of setup. So we do something like that. So that's going to allow us to have a little bit more control over it, because what I'm able to do in a case like of that then is we'll start out with our standard S-curve. Now the values here are going to change a little bit, because the time input, we could have something up to minus 180, in which case, you know, that should be basically the full sort of input that we could provide there. So that we're going to say is 1. And then the other end of the scale, the time is 180. And we're going to say that that goes minus what? So I think that covers for the what we had previously in terms of the sort of inversion of the inputs. And then I'm going to set a couple of values here where f, it's within, let's say we get within probably like 2 degrees. I want it to be 0. So we can have a little bit of a deadband there. 2, 0, and we just set it that in between those, it's linear. That way then we have a little bit of a deadband wide in there, and we can easily then adjust sort of scaling of this. So let's test to make sure it's rotating okay. We might find that it's a bit slow and needs the speed updated, which it does, which is fine. So this is then where I would multiply this by rotation speed. And what we'll likely find is that rotation speed, we drop that way down. So probably something like 30, probably even lower again. So that rotated pretty rapidly. I might drop it to 15. Let's just give us a bit more control over it. We've got curve and then we've got a scale factor. Feels about right. Okay, so we're setting the turn rate. Good. So then in terms of with the heading, so we're using the vector to the target to determine the heading. Then we need to determine our speed. So the speed should really be based upon the distance from the target, is really sort of what we want to actually use there. So I want to look at something like AI motor set movement. We might call it, set movement. And I want to be able to do something where it's essentially based upon that distance that we are from the target. And I think relative to that sort of distance reached threshold. So as we get closer to the target, we should sort of slow down a bit. So I want to have another thing that what it's going to do is basically controlling the range in which we start to slow down. So slow down distance. So I think as soon as we get within sort of 2 meters, we can start to slow down. And then we can have an animation curve, distance to speed input. And what I do then down here is, so this is calculate the rotation to the target, then using that distance to the target. So that distance, I get the magnitude. I divide that by the slowdown distance. So if it's less than it, it's going to be 0. If it's more than it, it's going to be 1. And then I can say distance to speed input. I evaluate that. And that is going to be the speed input. And so the movement is just actually going to be that single speed input. And again, we might have a scale for that. So we might have a max move speed that we scale by. And what this will do is public void. So this one is going to control input move, and this will be input move y is equal to the speed. Now we could start to get fancier with this and be using x a little bit so that it's rotating and it's also strafing somewhat. That is absolutely an option that we would have. But in this case, we're just going to keep it fairly basic. So distance to speed input. So something like this will mean the closer we get, so the more that closer that input is to 0, the slower we get. Now we never want it to go to exactly 0. So I'm going to set that value to 0.1. So when we're more than our threshold distance away, more than that slow distance away, it'll go that it's full speed, otherwise it will start to reduce it. I'm going to change that scale factor there back down to 1. So let's test. This should now be able to move and move in a way that's following sort of a bit of a better setup. So it's able to turn and rotate and try and get there. But we can see it does move way too fast. So that move speed, we want to cap that a bit more. So that, I'm going to drop that down to half. So it's moving way too fast. That's better. Still moving quite rapidly, so we might find the rotation speed needs to change. That max move speed needs to go to like 0.25. Sorry, not 0.25, we want that. That was good at 0.5. Rotation speed actually needs to go down. The other thing we could do is, rather than adjusting the max move speed, which I feel like that should be a lot closer, with that faster turn rate. So it's better. That slowdown distance, because we do want it to potentially, when it's really far away, be able to go at high speeds. That slowdown distance, we might want to actually ramp that up so that it actually starts to slow down anywhere where it's within 10 meters. So that slowed down a little bit, but it sort of really did overshoot there quite a lot. So what I'm going to do is we just want to check and make sure how it's calculating that, make sure the slowdown calculation is correctly happening. So we're going to put in a breakpoint here and just check this. So we can see the magnitude just like that. That means our speed input is near 1 because our slowdown distance was 10. So the magnitude of that vector is quite large. So we probably can make that slowdown distance even larger again because it's obviously going way too quick. So probably something where it's like within 20 meters. That's a lot better. Still, now it did turn a bit of an odd direction there, so we probably want to check and see with these angle deltas the kinds of values that it's getting, because it's possible that it might be getting an angle delta that's actually too large. I don't believe quaternion angle reliably gives us the shortest angle. Now that one, 120, definitely is the shortest angle, but it may not always give us the shortest angle. So I'm going to put in a check here, and mathf absolute of angle delta is greater than or equal to greater than 180. I'm just going to log that out just in case it happens. I just want to be sure because I'm not certain it does give us the smallest angle in between. In which case, that's something that we do need to take into consideration. So let's try dropping the move speed again. The other thing we can do is if there's a large angle, have that actually lower the distance. So, because 0.5, definitely in that case, it's way too slow. We do want the max move speed to be 1. And that's something where it looks okay with that, moves over to the point. That's pretty good. So we can check again. With going over to the TV, let's get it heading to a different one. So browsing at the bookshelf, so we can see it does, it has a pretty large rotate around. So the rotation speed there, if we up that to 30, let's take a look at how that looks. So balancing these values is always a little bit tricky. 30 works a lot better. That looks pretty good for the movement there. It's going to move over to it. It's going to browse at it. It's finished browsing. Heads over to toggle power at the TV. You can see the navigation mesh, its thing is updating there. So we potentially, when we are moving, need to update the navigation mesh's position as well. We saw the NavMesh agent was sort of moving a bit weird there. So what we actually want to do is we want to make sure we're overriding the position and keeping it so the NavMesh agent is in sync. So what I would actually be doing here is, in the cases, pretty much I would actually do this the entire time. So a void late update to linked agent, and its next position is equal to, so we could go directly for the AI motor. Now it doesn't have one for asking its direct position, but we could just set that always to our position, because we did notice when the character's moving, the circle, the indicator for the NavMesh agent, is trailing behind it, and that could then mean we get odd behaviors with the path finding because it's going to think it's at the wrong location. So that looks good. Moved over. Now, where it's moved to, can see that it kept moving. So that is because we're probably going to find, we're not getting any cases of that, which is good. When we need to stop movement, we are going to need to go and say, hey, AI motor, set movement to 0. And AI motor, set turn rate to 0. We actually need to make sure they stop trying to move, because if we don't reset that input, it's just going to continue being whatever the value was. So now it's going to head over to the microwave to heat up food. It's going to get there. And notice it didn't actually stop until afterwards. So we want to just check and see what is happening when we hit this reaching the destination. We want to make sure that it does actually say to stop movement, because that's something where if it's not currently telling it to stop movement, it's going to just keep trying, and that's going to result in problems. This is going to head over to the TV. Gets there, it says reach destination. Now that sets it to idle, but nothing runs stop movement. So that's where we did configure the logic for stopping movement, but we didn't actually have that wired up. So what I would do is when we have reached the destination, we are going to say movement and turn rate go to 0. So that will stop it from actually continuing to do any moving at that point, which should then mean when it heads to something, it'll just stay there. So it gets to the point, stops. Once it finishes at the bookshelf, it's going to then, after a little bit, still browsing at that same bookshelf, straightforward. It'll then pick something else, hopefully. So it's going to microwave. So we can see there, its turn options aren't always great. So what I would generally do is, in a case like of this, if it's got a really high amount of turn to do, actually lessen the movement speed. That's something that I would often do in a case like of this. So our simple AI move speed, things like that are fine. But what I would do is serialize field, float, not float, this will be an animation curve. And so this will slow it down based upon the angle delta. This is the speed scale with angle delta. And how this gets used is we then do speed input multiplied by that, and we evaluate it based upon the absolute value of the angle delta. So larger angle, we can actually have it reduce the speed. So if I set this up, and the initial version will just look like this, where the value, or the time input is 180. So we can just load this back up again. So what this would mean is at a really high value, really high angle, it would go at max speed, but we want to change that around. So we want to make it that this corresponds to a value of 1. So at very low angles, we can go full speed. Very high angles, we want to really lower the speed down. Never dropping it to 0, but just lowering it. So this will just make it so that it's not going to try and rotate as fast when it needs to. So it's not going to try and move as fast when it needs to rotate a large angle. So it should give us better performance with it. And what we'll probably find then is we can reduce that slowdown distance as well. So once it's finished browsing there, so that it's focusing a little bit on the turning, still not great. And that's a case where the point that it picked wasn't really a great direction for it to pick to turn. So we might actually change the rotation speed, again, just flipping it. It's always good to just, it's very easy to get turned around with minus signs and that. So good to just check and see that we do actually have them the correct way. So it's going to browse there. So that looks okay. We'll see when it goes. So again, that's looking a little bit better. So it might be a case where we just need to actually, we did have the signs flipped and it just happened to be that it was making it worse. So that's again browsing. It's going to finish doing that. Goes to browse at the other one. And we might also find that the rotation speed, we just need the rotation speed to be larger as well. That's generally looking pretty good. Wanders over to there. So I do actually think we did have the signs correct originally, and then we flipped them again. So I'm going to change those angle deltas so that they are back to sort of what we originally were going for. So I'm going to change that back to 1. These are pretty easy to, I need to make sure those are properly set up. Otherwise, that's going to result in some very weird behaviors. But that's good. So we'll just do a final sort of test with that. Slow down distance is looking all right. And there's further changes we could do with that sort of prioritization in terms of whether we're wanting it to prioritize movement. And that's effectively what that speed scale with distance is it controls which one it's going to be doing most. Is it going to focus on turning, or is it going to focus on the speed there? So we could adjust this a fair bit so that pretty much anything more than, honestly, if it's got to turn anything more than, I would say, 60 degrees, we can probably start really penalizing the speed. So I think anything more than 60, we just really drop that speed right down, and so it focuses on it. So we can easily configure those thresholds for this, and that's going to give a better appearance to it. So it's always a lot of balancing with this. In each AI, you might find you probably need to adjust the balance differently. We also don't have any shortcutting for the paths, so it means it's going to be following a noisier path. We can see on the navigation display here, it is going to follow quite a bit of a noisier one. So it's keeping on going and heating food at the microwave. It's clearly really hungry. So it goes to TV, so it can see the path that it's trying to follow there. We could, again, usually with an AI, we're going to ramp up that rotation speed. So we usually bias more towards rotation. Now, the other thing we could be doing is if it needs to rotate a lot, we could also allow it to do a little bit of side strafing, because we've got that input control there now. And that's the big thing with having this going through the character motor like that, is we can have it work with other things. So it can work with stuff like being able to do strafing. It can work with stuff where it's doing jumping. Now it is currently, we do notice it can get a little bit stuck on obstacles. And that's something where we definitely would need to, when you're feeding stuff into the character motor, it loses those controls of, okay, how do I actually make sure that I can only move on valid surfaces? That's something that it does lose. So that's something to be aware of, that we often need to add in extra things like of that. So that's something that we will add in at a future point, where it's doing a bit more in the way of checks. So it's looking for where it's heading to make sure that it's actually fully valid. At the moment, because it's using something that's essentially player-based, it's able to kind of go anywhere. But it gives us that input, so we can see how we could do something that we can directly drive the inputs externally. And we'll do as a final check, we want to make sure that we haven't broken the player motor and that the player motor is still actually working. So player motor, still able to run around, so everything is still working as we would want it to for them. which is excellent. So we've got our player and our AI using a common base modem. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and I've put a link to that in the description below. If you've got any questions, chuck in a comment. If you're looking for other related videos, I have set up a video archive that there is now a link to in the description, and that you can search through the videos based upon descriptions, categories, things like that. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below. But until next time, bye.